we will start out with an equation here, and you have the equation of the form ax plus b equals k, where k is a positive number. So let's say we have absolute value of 2y plus 3 equals 19. Now again, remember, as we said, if this expression here is equal to 19, that tells you it is 19 units from 0. So that means you can be 19 on the positive side, or you can be 19 on the negative side. Okay, so that means we will set this up in two separate equations. You have 2y plus 3 equals 19 if it's on the positive side, and you can have 2y plus 3 equals negative 19 if your distance is on the negative side. So let's go ahead and solve this like we would any equation. You start by moving your 3 over to the other side. That gives you 2y equals 16. And then you divide both sides by 2 to get y by itself, and you end up with y equals 8. Okay? Now let's solve the other side, and this will give you, again, we start by moving the 3 over, which will give us 2y equals negative 22. Again, divide everything by 2, and this will give you y equals negative 11. Now, so basically what this solution tells us is if I take this y equals 8 or y equals negative 11 and plug it back into our absolute value equation, if these two solutions are correct, then they should be, this expression will be 19 units from 0. So let's go ahead and check our solution. We will use substitution to check our answers here. So let's look at, you have absolute value of 2y plus 3 equals 19. And again, remember, we are checking our solutions here. So if y equals 8, that will give you 16 plus 3. And of course, that is 19. Now we know absolute value of 19 will be 19, and you can see you end up with a true statement. So we know y equals 8 is a good solution. Let's look at y equals negative 11. Again, do the same thing, 2y plus 3. We will substitute our y this time with negative 11, and that will give us negative 22 plus 3, which will of course give you negative 19, and absolute value of negative 19 is positive 19, and again you can see we end up with a true statement. So it is safe for us to conclude that the solution set for this problem is going to be the numbers negative 11 and 8. Alright, for our next example, we are going to look at how to solve absolute value inequalities. And for that, we are looking at the form absolute value of ax plus b less than k, and absolute value of ax plus b greater than k, where k is a positive number. So our example here is absolute value of 4x plus 1 greater than equal to 21. Now, the first thing you need to realize is this is the greater than or equal to inequality, which means that the distance of this expression has to be more than 21 on both sides of 0. When you set this up, you will set this up as the OR compound statement. Okay, so 4x plus 1 can be greater than positive 21 on the positive side of 0, or 4x plus 1 can be less than or equal to negative 21 on the negative side of 0. So again, we'll go ahead and solve each one of these inequalities, and let's see what solutions we come up with. So we move our 1 over to the other side. That gives you 4x greater than equal to 20. Divide everything by 4, and that will give you x is greater than or equal to 5. On the other side, start by moving the 1 over, which gives you 4x is less than equal to negative 22. Divide everything by 4, and we end up with x is less than or equal to negative 11 over 2. So that is basically telling us that if the value of x is greater than or equal to 5, then this expression will have a distance of greater than 24, and if x is less than or equal to negative 11 halves, again your distance will be greater than 21. Now again, if you want, you can go ahead and check your solutions and see if both the solutions work. And we can conclude that your solution set is going to be all values that are less than negative 11 and half, including negative 11 half. Now let's go ahead and look at how this would look graphically if I were to put this on the number line. We are saying x is greater than or equal to 5. So if this is 5, we are saying x is all the values greater than 5 and including 5. So we will go ahead and put a bracket on 5. On the other side, you have x is less than or equal to negative 11 halves. So let's say negative 11 halves is somewhere right here. And again, we're saying all values less than negative 11 halves and equal to negative 11 halves. So we'll use a bracket again to show that we're including the endpoints. And so your solution set will be this section right here, which is negative infinity to negative 11 halves. And again, remember, we are including negative 11 halves. And on the other side, you have all the values including 5 and greater than 5. So that will be 5 to infinity, including 5. And again, we use brackets to show that we are including the endpoints. And you join the two sets by using the union symbol. Okay, so that was an example where you had the greater than or equal to inequality. Let's look at another example where we are using the less than inequality symbol. So we have absolute value of 3x minus 1 less than 8. Now remember, when you have less than 8, you are saying this expression is going to have a distance of less than 8 from 0. So when you set this up, you will set this up as an AND inequality. So you have 3x minus 1 less than 8 and 3x minus 1 greater than negative 8. Because less than 8 on the right side tells me this distance has to be less than 8, and greater than negative 8 on the left hand side tells me the distance has to be, again, less than 8. So let's go ahead and solve each one of these inequalities, and that will give us, let's see, we move our 1 over, then we divide by 3, which gives me x value as less than 3. And for the other side, move your 1 over. You end up with 3x greater than negative 7. Again, dividing everything by 3. And we end up with x is greater than negative 7/3. Now again, if you want to look at each one of these solutions graphically, you will see that we are saying x value is less than 3, which will be right over here, and we're saying x values are greater than negative 7/3, which will be, let's say, somewhere here. Now, if you guys remember when we talked about the and or inequalities, the or represented the union of sets and the and represents the intersection, and you can see this will form just one interval, and your x values have to be between negative 7/3 and positive 3 for your expression to have a distance of less than 8. So as a solution set, your answer will be negative 7/3 and 3. And again, you can see I am using parentheses to show that we are not including the endpoints in our solution set.